Hey everybody, this is Mr. Beckstrom, and today I want to take a look at example from section 3.2. This is number 4 in the homework, and we're basically going to estimate the graph of the derivative for each of these functions here, lowercase a, b, c, and d. I'm going to kind of put them over here. Now the way we do the derivative, remember what the derivative tells us. The derivative tells us the slope of the tangent line at some point x, right? So that's what our derivative graph is going to look like. It's going to use the same x values as our original graph, but instead of using the y values, we're going to use what we believe to be the slope of the tangent line at that point. So let's take a look at, let's do b first here. And the graph b is pretty easy because what we can see is that the slope, for example, at x equals -2 is just this 45-degree angle. So we're basically, our slope is going up 1 over 1, up 1 over 1. So that's going to give us a slope of 1. And it's going to give us a slope of 1 no matter what point x we, or what value x we pick on this function here. So at -2, we're going to have a derivative y value of 1 at -1, where it's the same slope of the tangent line at that point, which is just that up 1 over 1. So for the blue line here, it's simply just going to look like this. At every x value, we're checking for the slope of the tangent line at that value, and the slope is 1 all the way across. So it's going to look something like this. And that will be for, and we'll call that one, this little b, we'll call this one big B over here. Now for the next one, let's take a look at C. Now notice that at every, this is still a straight line, so the slope of the tangent line at every point is going to be the same. And this is also up 1 over 1, up 1 over 1. So we're actually going to get the exact same. Let me go ahead and just put it here. So C is going to be the exact same graph because it's going to be the same slope of the tangent line at every point on the original graph here. Now let's take a look at the red one here. That's A. And it's a straight line, so we're going to have the same slope for the slope of the tangent line everywhere on there as well. And let's take a point here and see if we can kind of guess the slope. So here we're going up 2 and over not quite 1, right? So maybe for this one here, we're going, remember the rise is 2 and the run is maybe about 0.8. So if I go up to my calculator and I just kind of do a slope of 2 divided by 0.8, 2 divided by 0.8, I'm going to get a rough estimate of about 2.5, and the slope is going to be the same no matter where I am on there. So I'm going to go up to 2.5 here, and that will be my big A. That will be, I meant to do that as a red line. Let me see if I can just write over there. Yep, that is going to be just big A. And then finally we have this D here. Let's see if we can kind of generate a slope. So that's right here. If we start here, we go up 2, we go over 1. That looks like it's pretty exact. So the last one, which is kind of green there, is going to be exactly at 2. Now remember that these are all straight lines, so the slope of the tangent line is not going to change from one x value to the next. But if we're looking at a parabola, it definitely will. But this is how we look at the graphs of these straight lines there. All right, if you have any questions on that, and that one was big D, let me know. And I hope you have a great weekend. Thanks.